Hi. So being first up, I'm not quite sure how these presentations are supposed to go, so this is an experiment. And what I'm going to talk about actually is trying to leverage administrative data to answer interesting questions. I'm going to use a sort of extended example of trying to look at the effect of lead poisoning on children's test scores. But my purpose is to try and think about what that illustrates about advantages and disadvantages and problems of using administrative data. So the premise that I'm operating under is that there is a lot that could be done with administrative data that isn't being currently done, and that merging these data sets together especially could give very large samples that could then shed light on lots of interesting questions. And so the example that I'm going to talk about is related to work on environmental justice, and a very specific example. We know that there's a racial gap in test scores. We know that it's narrowed over time. And so a question I think that comes out of this literature is we know that African Americans are disproportionately exposed to pollutants. In my work, almost any kind of pollution that you look at, African Americans are more likely to be exposed than others. Interestingly enough, that isn't only a function of income. It seems to be more a function of racial segregation in housing. And also, to the extent that there are more low-income people, then people have less resources to try and counteract the negative effects. So I think it's plausible that differences in environmental exposure could explain some of this racial gap in test scores, but this is a very hard thing to get a handle on. So I'm going to look at it with respect to lead poisoning. Lead, I guess, is a good thing to look at when you're thinking about test scores because we know that it causes brain damage. And the way that it does that is by mimicking calcium in the body and interfering with all sorts of systems, not only cerebral ones, but also other systems in the body. And children are particularly sensitive. So they're sensitive because they're more likely to ingest lead. Also because conditional on exposure, lead is more likely to be absorbed. If there are any neurologists here, they'll probably not like this characterization, but it's often said that there's a blood-brain barrier that protects the brain from some sorts of toxicants, and that isn't fully functional in young children. So the lead is more likely to get into the brain than it would be for an adult who was exposed to the same thing. And also, given that your nervous system is still developing, it is likely to have a bigger effect. So children are at risk. And how big of a problem is this? Well, the data that we have that actually measures lead exposure comes mostly from the National Health and Nutrition Examination Survey, where they take blood samples and measure lead levels. And this suggests that about 500,000 preschool-aged children still have elevated blood lead levels, and also that disadvantaged children are disproportionately affected. So lead levels are 50% higher for African American children on average, and 30% higher for low-income children. And actually, the main source of lead, despite all of the recent publicity about lead in water, which is definitely a problem when it occurs, the main source of lead is still lead from lead paint. And so older housing with peeling paint may be a source of lead exposure. So we have some data from the NHANES, which is a survey. If we're thinking about a city like New York and saying, how many kids in New York are exposed, we don't really know. And the estimates that you see, if you Google lead poisoning, those are all based on looking at poverty rates and the age of structures. So they'll say, if this is an area that has old houses and a lot of poor people, probably this is a place where they have a lot of lead poisoning. But that's kind of the best that we can do. Now, you would think that since kids are tested for lead, that we would have much better data on that. But there's a lot of problems with the administrative data on lead. And a huge problem is that even in states that mandate complete testing, which is only 11 states out of 50, and in the Medicaid program, which also mandates that children be tested at least twice, only a fraction of children are actually tested. So in Medicaid, 41% of children have a claims record that says that they were tested. So pediatricians just aren't doing this. And so that makes it difficult to even construct a rate, because if you're not testing everybody and finding the cases, then how do you know what the rate of lead poisoning is? And so just some examples here. You know, Pennsylvania has very high childhood lead poisoning rates, especially in Philadelphia, which is a lead hotspot, but only a quarter of children in Pennsylvania are tested by age 3. There are 3 states which explicitly say that they don't recognize the federal requirement to test Medicaid children, so they don't offer lead testing through the Medicaid program. And the best states, though, and I'm going to be talking about one of those, Rhode Island, test 80% of children repeatedly. And then the worst states are states like South Carolina, where they only test 5% of Medicaid-enrolled children.
So this is a little surprising to me, because this is a practice standard.
Mm-hmm.
Pediatricians are taught to do this at age 1 with an hematocrit. So I'm really surprised to hear this. I wonder how this correlates with the number of children who receive whatever care they get from other than a pediatrician. Family practice, nurse practitioners.
No, you can't blame it all on the nurse practitioners. They're definitely, there's...
I'm just wondering,
yeah.
because it's a surprising statistic to me, actually.
Well, I think it is surprising, but there are a lot of things that doctors aren't doing that they're supposed to be doing. You know, when I look at any kind of practice standard, I typically find a lot of people who are not following the practice standard for one reason or another. I think most of these doctors would say that, well, they're not testing the child because they don't think the child is at risk, right? So.
Could it be testing and not recording, or is that just doesn't exist?
Well, that's unlikely because you can bill for it. So why would you do it and not bill for it? Okay, so one issue with lead testing is it may be kind of a victim of its own success.
Sorry, a delayed comment. What about discrimination? To be blunt, white doctors not doing due diligence. I mean, it's cheap to throw out explanations, which seems to be a paradox, but
Yeah, I actually don't even know how you could look at that, given the data that's available. So it's a hypothesis, but I have no information about it at all.
is there any other context where I thought there was some literature on differences by race and diagnoses? And,
Well, there's differences like in treatment.
yeah, and so then the question is whether or not that could actually apply to this sort of.
So like the women's heart disease, for example, wasn't there some recent?
Yeah, I mean, it's been well studied. You can identify, the ethnicity of the doctor and the consequence of the nature of the diagnosis. I'm just wondering if there's been a corollary to that, so given how
Maybe.
surprised you were.
Well, it may just be that when I
Right.
practiced, I used to do it, so I'm surprised everyone does it.
Yeah, well, they don't. So,
They have the right to bill. They have the right to do it in many places. They have the right
and
to bill.
as Dan is saying, it's a practice standard, so there's
There are lots of things pointing in favor,
right.
but
The Medicaid program says that all children in the Medicaid program are supposed to be screened at least twice by age 3, and they're not. So anyway, one reason why people may be kind of lax about testing is that, lead has gone down a lot. Lead in the air has gone down a great deal since 1980. And the old standard was this 10 micrograms per deciliter, and the number of children hitting that standard has declined from 8.6% to 1.3% in 2004. So I think a lot of people, at least before Flint, thought, oh, well, this is a solved problem, right? So why do we need to spend resources on a solved problem? These mandates are from a time when there were 10% of kids who had high lead, and now nobody has high lead, so why should we bother doing this? But the point is that even much lower levels of lead may have harmful effects, and that was one of the things that we were trying to look at in our study. So some additional problems with the administrative data, which I think are more typical of all kinds of administrative data, is generally you may have data on everybody, but only a limited number of variables. So this data, you usually only have the child's age, gender, and where they live. And so you don't know anything else about them. You don't have background information about the family. You don't know about their siblings. And there's no outcome in the data, right? So you have a bunch of data. You don't know what the at-risk population was, because only some children are tested, usually children who have some evidence of poisoning to begin with, and then you have some number that says this many children tested positive for lead, and you have no other information. Okay, so what can you do with that? Well, in our Rhode Island study, we started with an advantage, which is that they are pretty aggressive about lead poisoning. So 80% of kids are screened by 36 months. A lot of them are screened more than once. So the median in our data is that you have 4 tests for lead. And in the lead testing data, you know the date of the test, the location of the child, how the test was done, and then the blood lead level. And we could get, I have to say, my co-authors did this, not me. 2 of them are embedded in the government in Rhode Island, and they were able to get the Department of Health and the Department of Education to cooperate to merge the data, right? And so that sounds like a totally trivial thing, but it's so hard, because it means that one group has to give the other group access to their data. They both regard the data as totally confidential, and confidentiality is sacred. And so, if you can't let your data out of your site to give it to the other people, then it can't possibly be linked, right? So we're able to get this link, and then we have test scores for public school reading and math in grades 3 to 8. We also know free lunch status and whether they have an individual education plan. But we still, from those 2 administrative data sets, don't know anything about the family background, because that's not recorded. So the only thing we would know is free lunch status, which is often in education data sets. So then we further linked that with the vital statistics natality data, the birth certificates. And the birth certificates actually have quite a bit of family background information. So they have maternal race, which again is missing from these administrative data sets and often missing. You have ethnicity, education, marital status at the time of the birth, the child's birth weight, the child's gender, and some information about maternal behaviors like the use of prenatal care. Okay? Also, you can use this to link siblings, because you look for kids who have the same mother and link them together. So we ended up with a final sample of 57,000 children where we have all this information, and a lot of them are linked across siblings.
Does it have place-based information? I mean, you could find an address, and the address might...
Yeah, so we have the exact address actually from the lead testing data, because they want to know where the house is,
Right.
where a kid was living.
So there you do see clusters, presumably. There are areas, some like New York City public housing has just...
Yep, I'll get into that more in just a sec. So one interesting thing you can do when you have 57,000 observations is look at what the distribution of lead levels is compared to test scores. And so this is looking at the start of our data, which goes from 1997 to 2004. And you can see the whole distribution of lead levels is higher for African Americans than for non-African American children. It's sort of interesting to look at this cutoff here, which is the old threshold for concern, right? So there are not that many kids over here, although African Americans are much more likely than non-African Americans to be there. But you see a lot of kids with levels, around 5, 4, right? And there isn't a lot of evidence about what is the effect of those kind of lower levels of lead. And then you also see this gap in test scores. So this is the reading score at grade 3. And again, the distributions are clearly pretty separate from each other, okay? So that's 1998. And then what we can do with this data, which I think is a big improvement over some of the previous studies and really stems just from the fact that the data is better, is that we have repeated measures of both lead levels and test scores, right? So we can relate them together. In Rhode Island, they also had a big program to clean up lead, which I'll talk a bit more about in a minute. So we can both use the variation because of the program to say what is the effect of lead and provide something in the nature of an evaluation of this policy for lead cleanup. Okay, so this lead policy, first of all, the Department of Health required that if a child had tested positive for lead poisoning in a home, that the landlord or owner of the house get a lead-free certificate, or they could be criminally prosecuted. And then the Housing Resources Commission launched a sort of parallel campaign that required all landlords to get a lead-safe certificate, but then also provided a lot of carrots. So they, not just sticks. They had training and information for landlords about how they could do lead abatement at relatively low cost. They had low-interest loans for landlords who could use that to do the lead abatement. The law that established this didn't actually increase enforcement. So there was kind of a threat there that if a child was poisoned in your home and you hadn't obeyed this, then maybe you could be sued, right? But there weren't explicit step-ups of enforcement. And this was all targeted on neighborhoods that historically had high lead levels. And so the number of certificates really take off. This is both of these types of certificates. And they're very targeted. So this is showing, now I'm blanking on the capital of Rhode Island. Providence. This is Providence, and these are census tracts. And so the red are places that have a lot of certificates, and the yellow are places with fewer certificates. So you can see that it's very targeted at specific neighborhoods. And then these were neighborhoods that had characteristics that meant that the people that were living there were more disadvantaged. So if you look at the correlation between the lead levels in the tract and the characteristics of the people in the tract, whether they were married, well, that's significantly negative. The mother's age at the birth is negative. Whether the mother's African American, that's positive. Whether the mother has risk factors for the pregnancy, that's positive, right? So these are disadvantaged areas where you might expect kids to have lower test scores for many reasons, not only because of lead poisoning, potentially. Okay. So if you look then at what happened to lead levels between 1998 and 2004, so this is a very short period, right? Essentially 5 years. What you're seeing is the whole distribution shifts, and where we had a lot of people at 3 and 4, now we're having a lot of people at 1 and 2, right? So that's very striking, I think. And then if you look at what's happening by race and income, where the proxy here for income is whether the child was a free lunch child or not, you see some convergence here, right? So the black and white rates are converging, and they're converging more than the free lunch versus no free lunch rates. So the paper, which I sent to Steve, has lots of tables and lots of robustness checks and so on, but I think maybe in a half-hour presentation that's not necessary. So essentially what we do is a little more formal than the graph. We look at blood lead levels as a function of the number of old homes in the tract that got certificates, controlling for a bunch of characteristics of the tract, of the people, and show that there's a first stage relationship there, that places that got more certificates have a lot lower blood lead levels in the children. And then, to be a bit more specific, there's an increase in DOH certificates reduced the average lead level by about 0.36 micrograms per deciliter. And so if you look at the places that got the most certificates, they're reducing lead by an average of 0.69 micrograms per deciliter. And the effects are larger for African American and free lunch students. So we estimate that you could explain about a fifth of the decline in lead levels among African Americans using this certificate program. Okay. So then we ask what effect that has on test scores. We have math and reading scores. We can look at scores over time. We can also look by different child characteristics. And what we see actually is, I think, pretty striking because, so this is for reading scores in grade 3. You see the black reading scores improve, and the white reading scores don't change very much. Okay? So this is a program that wasn't explicitly racially targeted in any way, but it's having a disproportionate impact on black children because they're the ones who are living in these places that have a lot of lead poisoning. If we look at different categories, if we look at whether the children were below, far below proficiency on the test, if you have higher lead levels, then you're significantly more likely to be below proficiency on the test. Most of that seems to be coming from moving this middle group to the below group and nothing really from the high-end group, which is, I think, kind of what you'd expect. For math, you see a big increase in the number of kids in the below proficient group. And there's a group here between 30 and 40, so they're basically coming from that kind of marginal group and becoming, sub-marginal here. So what we estimate is that the racial gap in test scores fell from 9.2 points for those who were born in 1998 to 6.3 for those born in 2004. So in the education literature, I guess people like to talk about a standard deviation of a test score. So that's from 70% of a standard deviation to 45% of a standard deviation. And for lead, the gap fell from 2.2 micrograms per deciliter to 0.9. And so what we estimate is that about half of the decline in the test score may be due to this decline in lead levels. So again, this was a very cost-effective intervention. It wasn't really very expensive to run this program. If you compare it to other types of education interventions, it's really very extremely inexpensive compared to something like reducing class size. Okay, so I think, as I say, this is meant to be kind of an extended example. And I think one question that this raises is, well, why don't we see other studies like this of things that are very topical? And of course, people here who've tried to do this understand how difficult it is to get access to these data. So it's a little bit ironic that at the same time that we have so much more capability to process these data sets and link them in all kinds of ways, we also have more and more concerns about privacy, which are making it very difficult to access any administrative data, and at times things go backwards instead of forwards. Also, I think something people don't think about that much is it's sort of nice to wave your hands and say, well, why can't the Department of Health and the Department of Education join these data sets and do this? They don't have the capability. I think in a lot of state houses, if you go and look at the people who are there who are supposed to be doing things like producing mandatory reports, the number of staff has declined dramatically while their demands have stayed the same or increased. So they're all scrambling just to do the basic stuff that they're supposed to do, and they don't really have the capability to do this kind of stuff, even if they had the training to do it. Often computer capabilities are really amazingly limited. So if you want to find an IBM mainframe still in use somewhere, go to a state house or a local county government, and you'll see them using an IBM mainframe to do payroll or something like that, right? And it's like, well, you have to do payroll every week if we can't shut down the system because we have no backup, right? So it's all held together with duct tape and rubber bands.
And they overwrite sometimes,
Yeah,
because they can't store.
they don't have any capacity to archive stuff, so you think, oh yeah, we should be able to get data back 20 years. Well, forget it, we don't have that either. So, I often wonder about whether educating the public about what you could do with these data would help or whether it would hurt, right? Because then you might have a whole bunch of people who just said, oh, wait a minute, the government has access to, what? The vital statistics data have all this health information on them and people have access to that, that's terrible.
But
And
I even think that's a tough premise, educating the public. I kind of largely given up.
well, we're all educators, right? So this is what we do. We cannot. So I just, this is my last slide, and I just want to throw out a couple of ideas and maybe have some more general discussion about this. So if you think about, well, what could be done? People often, in the early childhood literature, there's a lot of work being done using Scandinavian data, and people will say, oh, they have such wonderful data, it's all linked together, and you can get data about everything. It doesn't actually exist that way. So if you want to use, say, Swedish data, they have, just the same as here, all this data which is in separate registers, and if you want to use it, you make a proposal, and you pay for them to do custom data merge for your project, and then when you're done with it, they get rid of that. Okay, so it's a much more formal system than people think, and much more controlled. So, so I think it's a good model, and one that could actually have some traction here if there were resources to implement it. Another thing which I have become aware of, though I don't know a lot of the details, is in the private sector, when companies have this problem, they can go to a vendor, a trusted third party, to take data, merge it, produce a de-identified data set, and then that can be used for the company's purposes. So one example of this, I've been using data on prescription drugs from a company that's called IQVIA. And so they have all this data, which is all prescriptions from all retail pharmacies. And I sort of thought, well, how could they possibly get around HIPAA to have this data? And so it turns out the retail pharmacies, and especially all the big chains like CVS, sell their data to IQVIA. It goes to this trusted third party, which merges it all together, takes off the identifiers, and then IQVIA gets the data. So they never have personally identifiable health information, and then they can use it for all their purposes.
And this is at the practitioner level, right? This data contains.
It's if you write a prescription to somebody, it has your name on it, your NPI, that's all there, and we know, what all the details.
The AMA went after them, and they lost.
Yeah, so I think it's interesting that the private sector can do this, apparently, that there are companies that do this, and we sort of haven't figured out an equivalent in the public sector. And then the third thing I was thinking about is that one thing that has helped me sometimes in the past is to have an example, right? So you go to a bureaucrat, and you have to look at it from their situation, in that they have a job, they're supposed to do a bunch of things. They might be able to help you out in their spare time by giving you access to data, but what's in it for them? Nothing. And what is the possible downside? if you turn out not to be trustworthy and the data is somehow released, they lose their job. So there's a big downside for them. They could even go to jail in some cases, right? So, trying to convince them that this is something that's not so extraordinary, has been done before, has been done in this way, might actually be useful to have something like a catalog of these different kinds of agreements so that you could find an agreement that kind of fit the situation. So those were just some thoughts that I had about ways to try and kind of open the vaults and get access to some of this information.
Thank you so much.
Can I ask you a question? So a few years ago, CDC lowered the permissible cutoff to 5 micrograms. And I wondered, I didn't catch on your slide, if there were a 5 microgram cutoff, how much, where would the two populations look?
Sorry.
Because you mentioned, in the tails, there didn't seem to be much difference. But in the body of the distribution, there was a difference around 5, wasn't there?
Well, there's certainly a peak around 5, actually, in 1998. Now, if you look at the CDC website, it says there is no safe level of lead and doesn't give any cutoff, right? Because I think the problem was that they were kind of inadvertently popularizing the idea like, oh, if I have levels below 5, then I'm fine, right? And they,
That's our state cutoff, so you get a level like that, the way it's supposed to work is you get a call from a nurse who's working for the Department of Health and asks for the records, and then they go out to the house in New Jersey.
yeah, another thing actually we did with this data, we did a little conference for educators because often the kids with, lots of kids have low levels of lead, is what we learned from this, and it does have an impact on their test scores. It also has an impact on their behavior. So kids are often labeled with some sort of mental health problem when maybe their real issue is that they have some low level of lead poisoning. And so for teachers to be aware of this might help them in dealing with these children.
So if you take the 5, if you look at the dominant part of the distribution, the density plot, how many of those kids fell below where they should be on a reading score? That would make the point that there is no safe level.
Yeah, well, that's what I think we're showing a decline in test scores for each one unit increment above 0.
Okay,
yeah.
that's
So we're still showing if the mean is 2 or 3 micrograms per deciliter, that's still associated with a lower test score. Yeah, and then we actually have a companion paper where we follow people longer and look at the juvenile justice system, and we see an impact there also.
So I thought those were two wonderful talks. One problem with following wonderful talks. I'm actually not sure what I should say. And that's in several senses. One of them is I hadn't heard Kate's presentation or seen it before she gave it, so this is going to be a real-time reaction. So I think what might be most useful is to deviate from the slides, which were actually a comment on Janet's paper more than anything else, to put on the table what I perceive links the two talks and links the conference, the workshop, in terms of the sorts of challenges that exist. And I want to put that at 2 levels. One of them is knowing the work of the people on the program, as well as something about what they're going to present. There's a different vision of modeling socioeconomic behaviors and outcomes than is standard operating procedure in the sorts of quantitative economics where I dwell. And what I mean, to make that a paradigmatic example, is think about intergenerational mobility. To this day, in the front page of the New York Times, there's a notion that the right way to think about intergenerational mobility is there's some scalar representation of a family. It might be permanent income, it might be their rank, depending on your preferred measure. And there's a scalar representation for a child. And in essence, you look for a correlation between them. If you're going to do something statistically sophisticated, you might allow a little nonlinearity there. But at the end of the day, there's a fundamental idea, which is scalar maps to scalar, and that the objective of the analyst is to understand that particular mapping. Now, if you think about the presentation today, there's a really very different vision of the transition of socioeconomic outcomes. And what I mean by that is that if we think about Janet's prenatal work, for example, all of that says that there's really a complicated vector of initial conditions. And so the notion, if you would talk about what it means to say you condition on the family, that you would reduce it to a scalar is missing something fundamental. And I think that the fetal origins hypothesis, at least one way to interpret it, is trying to move beyond this notion. There's some scalar notion of income that's a sufficient statistic. In fact, there's not a scalar that's a sufficient statistic. There's many things that matter. Now, if we take Kate's presentation, she said something, again, it's very fundamentally different relative to the way that we conventionally think about mobility. And that is that one doesn't map a statistic, a scalar about the family, or the experience of a child to the eventual adult outcomes. One actually maps a vector. And unfortunately, that vector has two dimensions. One of the dimensions is there's a plethora of characteristics we're interested in. I know that economists have deserved the mockery of psychologists for using the phrase non-cognitive to talk about things that go on in the mind, but you are a little bit out of date. We have belatedly converted, we now call it socio-emotional skills. All right, so but the serious point again is that there's a certain vision in this type of work which says cross-sectionally that individuals don't reduce down to useful objects such as human capital, or for that matter, parental income, so on and so forth. And that really, if we're thinking through this process of intergenerational mobility, what we want is a rich conception of the initial conditions, including the biological dimensions, which of course links up with the genomic work we'll hear about next. And then we need to have some vision of the dynamics that work through trajectories. So at the end of the day, what one has is a conceptualization of a high-dimensional trajectory mapping into another high-dimensional trajectory. Now, that all sounds well and good abstractly, and what this conference is about is actually how to think about operationalizing it. And I think first thing I want to put on the table with relevance to that, I think that at least is one of the unifying principles for the notion of economic data engineering. In other words, is to say that as we enrich behavioral models, and so for the non-economists here, there's a cliche amongst economists that economists are fantastic at answering questions and terrible at formulating them. But then the serious point is that there's a certain logical formalism in the way that we do business that I think is invaluable. And where you see the progress in the frontiers of contemporary economics would be introducing behavioral, psychological realism into these models, or introducing the whole notion that there actually is a genotype that has consequences, or introducing the notion that social influences matter, or introducing the idea that there is a whole notion of what I'm going to call normative considerations, or one might call identity, so on and so forth. And so what I'm trying to put together is that I think that if you think about the different, it may seem like we're speaking different languages, actually we're speaking the same language, and it's trying to somehow expand the way we would measure things in such a way that respects both the cross-sectional richness in terms of the objects that matter, as well as the complications of the temporal dynamics. And that's awfully hard stuff. I mean, if you think about Ed's work on measuring the heterogeneity of treatment effects, I mean, that by itself, leads to very deep identification issues. And so I think that, as I said, the first thing I really wanted to put on the table is I think that underlying the visions of the different participants here, and for what it's worth, my own on intergenerational mobility, is that we actually need a different language even to talk about what mobility means. And so if you ask me what it is, it's actually thinking about what are the level sets for childhood initial conditions and exposures that lead to similar outcomes. That's not a correlation or anything like that. And so I want to put on the table in thinking through the value of the data that are available, that they're actually leading to much more complicated models than are conventional in quantitative social science. And I think that they are going to lead to issues of how do we measure inequality, how do we measure persistence, so on and so forth. The second general observation I wanted to make is that I think that there's deep challenge, and by the way, and everything I've said there is actually a challenge for econometricians. To some extent. So what are the right ways to conceptualize the construction of these statistical models? It leads to areas called functional data analysis and like. We're actually mapping trajectories to trajectories, not variables to variables. The second observation I wanted to make has to do with the way to do social science as opposed to econometrics or statistics. And this is something that statistician Bert Singer's written about, Jim Heckman's written about, and they've written about together, and it has to do with what's called abduction. And what I want to put on the table is the following, which is I think a thing to think about with the richness of these data, is they lead to new challenges in how one aggregates information from different sources. I mean, think of the, kind of the differences between what you would put on the table in terms of we know these specific things about the biological pathways by which lead influences brain activity, to taking the sort of administrative data that Janet puts on the table that allows one, using the cross-sectional variation in the timing of the lead abatement, et cetera. How do we put that into a coherent vision to evaluate a policy? This isn't be a nice matter of writing down standard statistical decision theoretic environments in which you have to do calculations. It has to do with a different issue, and that's why I mentioned Singer and Heckman as examples of it, which we don't, again, I think is a frontier, which is how do we aggregate information from extremely different types of sources into answering these I'll make it concrete, these types of policy questions. And so in the philosophy of science, it's referred to as abduction, and so a little jargon for you. You all know what deduction is, that's logic. Induction is the law of large numbers, and actually abduction is what science is about, which is how do you draw the best conclusions from different sources of data. And to be blunt, there is virtually no formal work on that. Now, the only place you do have formal work actually is in computer science, but it has to do with developing expert systems essentially to evaluate hypotheses. I just want to put those on the ground as I think as organizing principles for what I think unites what might seem to be very disparate perspectives on how to analyze these data. So that's kind of the big picture stuff I wanted to say. So with references to Janet's paper, I want to say something smaller. Not that the paper was small, but it was more specific. And that is to say something about the way that there's been a change in the use of data by economists, a data revolution, if you'll forgive the word. And when I call this cheap talk, is I wanted to actually make an argument in thinking about the emergence of new directions in data sets. They actually do three somewhat disparate things. And then I want to make a little plea for the fact that econometricians and theorists aren't quite out of business yet. Okay, so what do I mean by that? Again, this may be old news to other disciplines, but I think within economics, what one sees is an expansion of the types of data that are used. And I want to argue that all of them, at least conceptually be thought of as how do they help us identify stuff. And so I want to claim that there's really three dimensions to thinking about this, the emergence of big data or different data, et cetera. And that the first is actually, it's simply more. In other words, people now have large data sets. So it's one thing to say that I had the panel study of income dynamics, in which I could estimate the intergenerational elasticity of income. It's a different thing to say I have IRS data with millions of people, in which I can do the same thing. Now, in my judgment, that's the least interesting way to think about what it means to move to administrative data, which has substantially large samples. The reason I say that is it's not that the issue with more data is not simply that I have a single statistical model and lo and behold the standard errors are smaller, but actually I think differently about the enterprise of constructing a statistical model. And that's really what much of the big data and machine learning is all about. And I'm going to, and what I mean by that is that when one has a data set, one thinks about the data through the template of a model space. There's a collection of statistical models of the candidates that we use to think about the organizing this morass. And what these very large data sets allow one to do essentially is to think about rich model spaces through which to evaluate the data. And of course, standard operating procedure in any empirical paper you read isn't a column that represents the regression you report. You report like a sort of standard operating procedure, a table, a set of regressions. The idea here is different in the sense that it says that because we have large amounts of data, we can actually search over many candidate specifications and engage in model selection in a way that's qualitatively more complex than the initial models. Where that becomes operational is that this actually allows for much more interactions and non-linearities, the sorts of things that are typically, in a relatively parameterized way, explored in conventional data sets. But the point of machine learning is nothing more than a particularly tuned-out parameter statistics. It doesn't mean there aren't advances in terms of ability to efficiently identify things, but it's the same principle. And so the first thing I just want to say is that I think the revolution, as it were, asking about new data sets, really one of the questions to ask is how do we relax the dependence on functional norms around here? And I want to use that for parametric specifications. And that allows us, and I think that a useful way to think about that is that we think about the data via a model space. The inference you draw from the data have to do with the probabilities, the weights we assign to the candidate models in the space. Well, now, lo and behold, I have much more data, which means I am allowed to investigate a larger model space, and that's where the standard error idea comes in. In other words, with large data sets, my ability to assign differential weights to the different models is qualitatively changed. I want to distinguish that between what I'm going to call accurate data. In other words, the second thing that has happened is the capacity to simply better measure the phenomena that we're interested in. And I think that Janet, actually, she emphasized that in her presentation. I thought that understanding the contributions of the paper, which makes her the rarest economist that ever lived. But the serious point is that, in addition to just saying there's more, so we can think differently about what it means to condition on a model, there are issues of the precision of the objects that we're looking at. And so, I think that, that can be done in several senses. One of them is no deeper than to say that with these more comprehensive data sets, the issues of sample selection correspondingly diminish. And so if one thinks about the distinction between the panel state and income dynamics and all attrition versus IRS data, one has a different vision of what the universe is being observed. A different dimension may not be the cross-sectional, it's actually the temporal one. And so you may know that Twitter data is useful for predicting unemployment movements. And the answer to that simply is it changes the frequency at which the data are appearing. Now when I say that's more accurate data there, it's more of a signal extraction problem. But again, the principle is the same. In thinking about why this stuff matters, I guess one good example is actually on poverty measurements. The term to administer data, thinking about my colleague Chris Meyer, who's worked with Sullivan and others, has shown that the characterizations of the appropriate rate poverty ratio to calculate really do change when you have large universes of candidates. All right, and I said one has to be careful because one interesting example is the PSA data versus the tax data, and what one finds in the Chevy with Zoom data on the size of the IGE is that yes, the IRS data has many, many more people, but actually the time horizons are different. And so if your concern is extracting notions of permanent income, more is not necessarily better, it's simply more and different. Now the third has to do with the self-defined data engineer, which I found in the program, and that is that the data can also be qualitatively different. And that's the third thing I want to emphasize, which is that it actually represents another dimension to all of this is the idea that many of the things we're interested in, we have to actually think about new ways to construct data in order to make these meaningful constructs. And I think the two obvious examples are the distinction between the use of kinship structure to talk about the role of genotype versus actual genomic measures. That's another example I would put on the table close to what you do, which is a distinction between the traditional way of modeling social interactions, which is to take ex-ante groupings of individuals. They may be very sensible. It can be race, it can be ethnicity, it can be gender, or it can be census tract, etc., versus data that actually are constructs of statements that can be self-reported. That's a separate issue about actually who's connected to who. And here I think that that's actually very much a frontier, and Andrew has a paper, Economic Data Engineering, specifically on this question, which is how do we alter the identification problem, the construction of data that is a better way of thinking about the things that are actually the objects of interest in the theoretical models. And so I think that there's really just three different ways of focusing on how these data affect identification, and they really are quite different. Okay, now relative to Janet's paper, I complained to her before this, which is it's not really fair to ask somebody to comment on an excellent paper, because there's not really much to say. And I don't really like giving compliments. All right, so. All right, so the serious point is I want to say that, again, that's why it was, the first one is not a focus of the paper. This paper is not about using fancy, non-parametric ways to estimate the relationship between the data. I think that's a fair statement. This is about accurate data and new data. In other words, it's saying that there are ways in which you could account for the measurement error in the blood samples via the instrumental variable strategy. Furthermore, the combination of the comprehensiveness of the data set along with the interventions of Rhode Island, that was a new way of actually measuring what's concerns about identification. And the identification problems came in the following way. And that is that at the end of the day, you have observations of children. They're in homes. Some of the homes have certificates, some don't. They live some in neighborhoods that have many certificates, some don't. And you need to think about the endogeneity problems. And you also have to think about unobserved heterogeneity. And so what I extracted from the paper were three identification problems. One is the self-selection of the neighborhoods. It means something to say the child was living here at this age. That's distinct from saying the neighborhoods themselves have characteristics you can't model. Now, the other identification problem, again, I think it seemed to me was the housing unit. The fact that a parent elected to live in a home that had a certificate or not, that's a meaningful thing because of the lack of enforcement. All right? So I put this on the table because, of course, the paper knows about all these and goes through arguments on how to address them. And so there's going to be, and so there's an idea here which basically says that you can think about, the standard, an instrument of variable strategy, but there's a certain logic to it, which is asked, you think about the child at birth, and you ask, what's the conditional probability that when they're at the school at the age of exposure, will there be a certificate there? And the idea is to use temporal precedence as a way of constructing an instrument to address these identification problems. And so at the end of the day, one ends up with a system of equations in which you can sort of think them through. And you write down a system of equations and ask, what's the nature of the instrument? The nature of the instrument is I have a set of variables that affect the probability of a certificate at birth. Those are measured at the neighborhood level, if I understood correctly, and some of them are interacting with other characteristics. And what's going to drive everything is that conditional expectation of the certificate, given the subject condition on, is going to instrument for the level of lead in the relevant equation, which is a mapping of the lead exposure measured by the blood to the test score. So, I guess so here's where I was saying this is the plea for the old-fashioned stuff. One thing which, again, if you tell me I missed it, that's the easiest answer. And that is, this model is actually over-identified. In other words, you have many instruments for the specific thing in the system. And I actually think it's important in this case to think about whether or not the over-identifying tests say that this is the right way to think about the problem. What do I mean by that? It's a very big statement. In other words, it's one thing to say that I have one instrument, first one observable. You actually have multiple instruments for the same thing. And testing whether or not the over-identified restrictions are met here actually is, I think, very important. And the reason for that is that you have a number of, what the paper has are proxies or character observables for a neighborhood. The worry in the paper is, what if there's other stuff about the neighborhood I can't see? An effective way to address that is to say all the things I have that are observables for the neighborhood, the way they're predicting the test scores is that they have the weights, as it were, where I stick them directly in the regression, they're all proportional to their basically the predictions they give for the certificates. So again, something a very old classical piece of econometrics facilitates identification here because if you go back to what were the challenges to identification, one of them was unobservable group heterogeneity. And in fact, embedded in the paper was a way, I think, constructively perceived. Now the second one's a trickier one, which is to ask, what is that epsilon in the behavioral equation? There's unobserved heterogeneity. So if one worries about self-selection or worries about unobserved parental quality, the question you need to ask on the instrument, and I think of those as kind of the things that drive epsilon, is the conditional expectation of the instrument of epsilon given the certificate of birth is same as the unconditional expectation. When that's violated, that's what the Heckman control function is. That's what it would mean to say there's parental quality in selecting neighborhoods. And so, arguments are made in the paper in favor of this. And what all I want to say is the answer to that, the argument there, that's not contained in big data. That's contained in the behavioral assumptions that are embedded in the exercise combined with the richness of the control variables that were used in constructing the regressions. In other words, the decisions to put in fixed effects here, to put in time trends in the neighborhoods, the arguments that are made, how do we deal with endogeneity, they make it easier to do them because you have more data, you get a few more regressors. This is not a paper that's overflowing with regressors. The identification conditions, which were this one, came down to the sort of reasoning that's essential in these exercises, which is to ask the question, given the stuff that I've conditioned on, is it credible to conclude that the sort of the unobservable heterogeneity correlation calculations that you're worried about, which come down to saying if the family lives in a lead-free house, maybe they're just good parents. I mean, that's the intuition. There's a way you say it, you don't have to correctly instantiate it, and that's what the paper is doing when it's trying to deal with the instruments, et cetera. What I want to emphasize is no deeper than saying, at the end of the day, that's using behavioral arguments, right? So economists arguments, places the modeling assumptions that are necessary for generating unbiased estimates and the like. And so my pleading was no more than to say that I think that relevant to a paper such as this, there's still a role for the good old-fashioned econometrics we know, and there's a role for theory, because one approach you could take to thinking about how would I make this as compelling an argument as possible is to actually write down a model of selection into neighborhoods, and then from the model, one would then calculate whether or not this condition holds. And that, for instance, mentioned Heckman's name a few times, that's what control functions do. They basically computed those conditional argument calculations and stuck them in the equation. For the purpose of this paper, you don't want to do that. You want to do something else, which is actually just see whether or not, from the perspective of theory, does the theory have this drop out? If it doesn't, then you ask whether the instruments are sufficient in doing that. So let me, I think I'm in over time. I am indeed, so let me stop there. Thanks.
Thank you so very much. That was